Hey everybody, this is your review video for 7.5, 7.6, and 7.9. So these are in a random order, just like they would be on the test. On the first one you have 3 log 2 plus log 7. Remember, if there's no number listed for the log, that's like a common log, which is base 10. So what you do on this one is they want you to rewrite it as a single logarithm. And so what you're going to do is you're going to put the 3, which is the coefficient, and make it to that power. So you're going to have 2 cubed plus log 7. We need log of both of those. Log of 2 cubed plus log of 7. So then, since your common base is 10, then remember your product rule. When you're adding, you're going to end up multiplying in your formula. So first 2 cubed would be 7, 8, hello. 2 cubed is 8, and then we want to multiply that by 7, so this would be log of 56. Log 56. Whoops, that was out of focus. There we go. Okay, on the next one, this is the one about the hydrogen ion concentration, and it's 3.3 times 10 to the negative 12, and we're going to use our negative log h formula. So we did a few like these on 7.6. Basically, we want negative log, and then you put the number listed, 3.3 times 10 to the negative 12. Okay, so that's your pH that we want. And then we need to distribute, or actually factor out, the negative sign. So this would be log of 3.3 plus log of 10 to the negative 12. So what we did was we changed multiply to add, so they're separate logs. Now the reason to do this is because when you have a common log, which is base 10, these things are going to cancel, so you're just going to end up with minus 12 here. So you have minus parentheses log 3.3 minus 12. Now you want to distribute your minus sign, so minus log 0.33 plus 12, and then just use your calculator. So negative log, you could just move it over to this 3.3 and then say plus 12, and that gives you 11.48, and they want it to the 10th, and so that's going to be approximately 11.5. So that's a pretty high pH. So just think of cleaning compounds having a high pH. Okay, the next one we just want to rewrite in log form. And so basically on this one, if 2 is your exponent, that's the number that gets set by itself. And then you put log, and the 9 is the base for the exponent, and so 9 is the base for the log. And then you put your 81. So that's what you want there. On the next one, you have log base 15 of 15 over y. So if you have the same number, that should be a hint that they're going to end up canceling somehow. So what we do is, if we're dividing, we change it to subtraction using the log properties. So this would be log base 15 of 15 minus log base 15 of y. And so log base 15 of 15 is 1, And so then you just get 1 minus log base 15 of y. On the next one, we have 3 to the 2x equal 19. So since this one is not a common base, you can't get a common base. Cannot get a common base. You have to work this differently by doing the log of both sides. So you have log 3 2x equal log 19. So to do this, we do our 2x in front of it. So 2x log 3 equal log 19. And then we want to solve for x, so we're going to divide by the 2 log 3. So x equal log 19 over 2 log 3. And then we just estimate this to the 10th. So we do log 19 over parentheses 2 times the log of 3. Whoops. Be careful so you don't do what I did. When I typed the 3, I forgot there was a space for the base, and so it goes over here. If you had to fill in your base, you'd put 10, but it should do it automatically. So it would look like that, and so you should get about 1.3 for your answer in this case. Okay, on your next one, we want to find the minimum and maximum values of log base 2 and log base 10 on the given domain. So this one is an increasing function, so you're basically going to do this as log base 2 of 5,000, and this one is log base 2 of 7,000. Then you're going to do this one is log base 10 of 5,000, and this one is log base 10 of 7,000. So remember, you're given a specific domain, and so it's not just like the regular negative infinity to infinity. You just plug in your numbers on the calculator. So you want to round this to 3 decimals, and so you should get 12.288, 12.773, 3.699, and 3.845. That's what you should get, and so let's do that on the calculator. Okay, so we just do log base 2 of 5,000. Control Enter, and that gives you your answer. Now, if you had several to do, you could have done it this way. Go with log base 2 of x as your function. So do add graph log base 2 of x. Then go to your table, and of course we wouldn't want to scroll down to 5,000, so you could do table setup. And change independent to ask. And that would be fast. So we go menu, table, edit table expressions, change independent to ask, and that's where we can plug in for x. You could put 5,000 and then 7,000. So that's how you get your answers. Okay, on the next one it says, suppose that the new employee starts working at $7.24 an hour, gets a 3% raise each year. Since they're getting more money, then you're using 1.03 inside your parentheses, because it's like 100% plus 3%. So it's going to be a bigger number. Now, what you want to know is what amount of time will there be when they get $10 an hour. So what we do is 7.24 times 1.03 to the t equal 10. So to solve this, we divide. We have 1.03 to the t equal 10 over 7.24. Okay, so when your variable is an exponent, you're going to want to take the log of both sides. So this would be log 1.03 to the t equal log 10 over 7.24. Now, if we use our exponent rule, we basically bring this in front, and I'm going to divide by this one. So I have the log 10 over 7.24, all of that divide by log 1.03. So you have a little complicated fraction, but that's how it's going to work out because you need an exact number that's not rounded. Otherwise, I guess use your ands button, but let's type this out and see what we get. Okay, so I would go to the calculate screen, or just a regular calculator part. Do log 10 divided by 7.24. Now I want all of that, so I've got to go to the front, do a parentheses for around all of that, and then divide that by the log of 1.03. You might want to fill in the tens just so you don't make a typo, but that's up to you. Okay, so I want this as a decimal, so I'm going to do Control Enter. And so when I do this, I get approximately 10.9 years. So it was 10.926, so approximately 10.9 years. Okay, the next one's actually really simple. It's just an example of a problem with being able to use a common base. So, in other words, you can do 3 squared is 9. So you have 3 to the x equal 3 squared, then that cancels and you just get x equal 2. So some of them are easy like that. If you cannot get a common base, remember you have to take the log of both sides and work it from there. Okay, now on the next problem, as a town gets smaller, the population decreases by 7% a year. The senior class has 320 students. In how many years will there be 100 students? So again, population could be decreasing because people move away or for whatever reason. And then it wants you to solve it without graphing. Okay, so on this one, what we start with is our original amount, which is 320. We're decreasing, and so instead of putting like 1.07, we have to do 100 minus that 7, so we get 0.93. Raise that to our x power. Well, it wants n for the variable. That doesn't matter. N, and then set that equal to the predicted amount, which is 100. So what we do is we put 0.93 to the n equal 100 divided by 320. Okay, so we can simplify that a little bit. 100 divided by 320 is 5/16. Which I think I prefer writing it as 0.3125. Because if we have a decimal on the left side, we probably want to use a decimal on the right side also. Okay, so now since n is your exponent, to get n by itself, do log to both sides. And so what we end up doing is bringing the n in front, so n log 0.93 equal log 0.3125. And then we just divide, so n equal log 0.3125 over log 0.93, and work that out. Okay, so log 0.3125, all of that divided by log 0.93. Okay, so that gives me 16.03 approximately. So that's 16.03 years. Now, the part I didn't write was the equation, which we did up here. So they want basically 320.93 to the n equal 100. So basically the very first line that I wrote was this equation. Okay, on the next one, this is one with some graphs, and you have log base 5 of x, log base 3 of 27x, and log base 1/5 of x. So this was like number 23 on section 7.5, which was basically problem 8 in your Math Excel. So this one had a formula. You have y equal a log base b of cx. And when you have that, that turns into y equal 1 over c b to the x over a. And so then just depending on what you have, you're going to manipulate your formula different. So this first one, you have a equal 1, b equal 5, and c equal 1. So what that means is it's going to be y equal 5 to the x. So that's for the first one. And so let's graph that. And it's going to be c. So if we just go to the graph, 5 raised to the x power, whoops, I pushed second. Five raised to the x power looks like that. Now there is another one that's also increasing, but notice that this one goes up closer to the y-axis. So that's the difference. Okay, the next one is log base 3 of 27, and so for this one we have a is 1, b is 3, and c is 27. So when we do that, it's going to be 1/27 times 3 to the x. It's x over 1, but that doesn't matter. So this one, when we graph it compared to the other one, 1/27 times 3 up arrow x. That one's the red graph, which is definitely further to the right. So that's this graph. It's further away or farther away from the y-axis. It basically looks like it's shifted to the right a little bit, but that's not technically how it worked. because this would be like a vertical compression. But don't worry about that part. Just pick the right graph, and it's the one further to the right. Now the next one has a log that's a number between 0 and 1. And so remember, if you have a base between 0 and 1, it's going to be a backwards graph. So let's graph that one. Our A is 1, our B is 1/5, our C is 1. So this would be in the form where it's 1/5 to the x. Okay, so parentheses 1/5 raised to the x. And so that's this black graph that goes like that. So I knew it had to be one of the backwards ones, and so we have to compare B and D. And the difference is, like, what is the y-intercept? That'd be a key feature to look for. If I disable the other graphs by unchecking them, I might be able to see a little bit easier. Okay, by pressing enter it didn't disable it, so I have to move my mouse pointer and do like this. Okay, so now you can see that you actually have a y-intercept that's relatively small. I guess you could have technically looked in your table and looked at 0 and saw the y-intercept. This one has a y-int equal to 1. Oh, I forgot. You can know that from like 1 being your coefficient. Yeah. So this would have a y-int of 1, which is the same as 0, 1. So this graph over here is pretty high up. This is the one that has a y-int of 1. So that's how you can pick the right graph. Okay, now on the next one, we want to rewrite using the power or product rules. So on this one, first step we're going to want to do is to bring the 20 in front. So we have basically 20 log t, and that's all we can do. Okay, the next one, they want you to solve the equation. So if it's minus, remember you have to change it to divide if you have a common log. So this would be log of 5 over 4x equal 1. Now, on this one, to get rid of the log, we have to raise it like 5 over 4x equal 10 to the first power. And so then multiply 4x times 10 and get 5 equal 4x, and then divide by 4. It wants an integer or a decimal. So remember, a fraction is not either of those, of course, and so we'd have to go 5 over 4, control enter, and you get 1.25. Okay. On the last page, it wants you to write this one in log form. Well, this is one where you may need to think about how you get 8 from 2. So 2 to the first is 2, 2 squared is 4, 2 cubed is 8. Now what we have though is a fraction 1/8, and so we need 2 to the negative 3 to be 1/8. And so that's why that's actually a true statement. what we want to do is change it to log form. And so think about writing log. And if this is 2, which is the base for the exponent, then that's going to be the base for the log. Remember when you're typing these, if you had to do it on a computer or on Math Excel, this is a subscript. You can't just type the number next to it. So we have log base 2, and then we put the 1/8 to be here, and then your exponent is what goes by itself, like that. So that's what they want. Okay, now on this one, it says solve by graphing, and so we put this as function 1, and the right side is function 2. So add graph 4 raised to the 2x, and then we need to press enter. There's our graph. I'm pressing tab and then going to F2 and pushing 200. Now remember, this would just be a horizontal line with 200, which is not visible yet. So you can double click this, or you can change your Y max to like 250. And so there you can find your intersection. Analyze graph intersection between here and here. That's 1.91109. They really do want a lot of decimal places, 4 decimal places. So they want 1.9110. Remember, if it says GC, that means graphing calculator. Okay, on number 15, we want to expand the log. So to start with, it's division, so we're going to end up subtracting. So this would be like log base 4 of 16 minus log base 4 of y. Now we need to simplify it as much as we can. Now it would be ideal if we can say 16 in terms of 4, and we actually can. So basically we're going to say log base 4, then the square root of 16 is 4, so I can say this is really 4 squared. That's how this is going to work out. Because when you have log base 4 of 4, that's going to be 1, and then, you know, you're just going to be left with 1 times 2, so we get 2. So 2 minus log 4 of y is your answer. Okay, then for our very last one, we have log base 2 of x minus 2. So since it's not parentheses, since the minus 2 is not in parentheses, this goes down to, not right to. Okay, so we basically have to graph it, and we're given a specific domain. So the graph for this one, which goes down to, is going to look like this. Pay attention to your y scale, because if that's 10, looks like this is going to have to be 2, 4, 6, 8, -2, -4, so forth. So this is going to be the graph that we want. So here we go. Log base 2 x, go to the right to be outside of the parentheses, then minus 2. So that's going to be that graph. Now we want to limit it to this domain, so that means you can set your window to have x minimum to be 0.5 and your x maximum to be 4. So it's going to look like that. So the difference between these two is this one's too high and this one's just right for your starting point. and then your ending point should be at the x-axis. And this is not, the ending point is not at the x-axis. And so be careful when you're picking these. But for my particular one, I needed it to be B. Okay, very last part, you want your range. Well, normally, it'd be negative infinity to infinity, but since you're given a specific domain, then it's going to be a specific range. And since the domain uses brackets, then the range has also got to use brackets, not parentheses. So if you're taking this test, on the computer, you need to use brackets instead. But basically, you're just going to say log base 2 of 0.5 and then minus 2. If you want to, put parentheses around this. Log base 2 of 4 minus 2. Okay, so then let's figure out those numbers. Log base 2, 0.5, and then minus 2. That gives you negative 3. So we start with bracket and then negative 3. And then the reason why I know that's our start is because it's an increasing function, because it's going up from left to right. So now I need to do the exact same thing. So I highlight it, press enter, change this one to a 4, and I get 0. It won't always be 0 there. You got to plug in your numbers. Okay, so that's the end of the review. Hope that helps.